Okay, so today we're going to be solving polynomial equations by graphing. So the first thing we're going to do is use a related function. Okay, so when you are doing this, the first thing we're going to do is replace your 0 with f of x. And then these values for which the function is equal to 0 are going to be the real zeros of the function. And these are called the x-intercepts of the graph. Okay, so remember we talked about zeros, x-intercepts, roots, solutions. Those are all the same thing. Okay, so here they tell you these are solutions, these are roots, these are zeros, these are x-intercepts. Yes, they're all the same thing. So whether something asks you for solutions, roots, zeros, or x-intercepts, okay, that is the same process. So your first step is always going to be to set the polynomial equal to 0. So that means you might have to move things over the equal sign. Like here, you'd have to move over the x and you'd have to move over the -6. We'll do practice. We'll do some practice questions. Okay, and then if you have this equal to f of x, this is when you replace 0 with f of x. Okay, so you either move them all to the one side or you are just going to set that equal to 0. And then we're going to use our graphing calculator to find the x-intercepts. Okay, you may or may not remember there is a 0 function that we use to find those. And in the 0 function, you have to have a left bound and a right bound. When you're finding those bounds, one has to be above the axis and one has to be below it so you can see the sign change. Okay, so the sign change when we go from a positive to a negative, that's where your zeros occur. Okay, so it says use a graphing calculator to solve each equation by graphing. If necessary, round to the nearest hundredth. Okay, so how many decimal places is the nearest hundredth? 2. All right, so the first thing we want to do is make sure everything is on one side so it's equal to 0. So we're going to add the 3x squared. If you are adding this over, just find your like terms. Okay, and then you should have a value equal to 0. So I want you to go ahead, combine those like terms. Okay, so you should have 1/3 x cubed plus x squared plus 3. I like that some of you are already grabbing your calculator to enter that in. That's excellent. Okay, so this is what you're going to put into your y1. Okay, this is your polynomial. So we're going to go to our y equals. All right, and then if you're doing the 1/3, you can put that in parentheses. You have to unless you use the fraction button. And if you do use the fraction button, sometimes they'll give you your answer as a fraction. Okay, so you have 1/3 x to the third plus x squared plus 3. Okay, and then remember, whenever you want to go to a standard graph, you can just go to zoom 6. That gets you your standard graph, and that should be all you need in order to see the intercept, but you might have to adjust the x's if you can't see where it crosses. Okay, and then we can see one x-intercept. This is going to keep going down on the left side, keep going up on the right side, because remember, if it's an odd function, what do the ends do? If it's an odd function, what do we know about the ends? They go in opposite directions. Yep. Okay, so we have one x-intercept. Okay, so we're going to go to second calc. And it's the trace button, but above it, it says calc. Okay, and then the second option is the 0. Okay, so you can just press 2. Okay, and then again with the left bounds, remember, try to get as close as possible to the intercept, and then just go 2 to the left, enter. I go back to the center and then go a few to the right. You can then make your guess, and then when it is the actual 0, it will say 0 on it. Okay, so it'll say 0. Your y value should be 0. Sometimes it might give you a scientific notation because it might be rounding to a very, very small value, but it rounds to 0. Okay, and then I always, if I'm rounding to the 100th, remember, you want to go 3 decimal places so that you can round appropriately. Okay, so the 8 is going to push that up. So your solution is just x equals -3. Oh, geez, again.
But my 8-year-old nephew, I was video chatting with him working the other night. He just goes like this. He goes, "What does this mean? What does this mean, Coco?" That's what he calls me. 6, 7.
All right, let's try the second one. Okay, so this one is very similar to part A, so I want you to see if you can do this one on your own. I'm going to move everything to one side. All right, and you should be at the step where you put this into your graphing calculator. So how many x-intercepts do you see at this time? How many? Don't tell me what they are, but how many are there? Oh, how many did you find? How many did you find? Yes, that's what I'm talking about, right? Okay, so you should have 2 different solutions here. When you subtract this over, there was nothing to combine it with. Same thing with the -3. So when you write this, write it in standard form. I guess I should have put that there. Minus x minus 3 equals 0. right, so then if it crosses the x-axis twice, you're going to have to do this process twice, okay? So you have two x-intercepts, so we're just going to go to second calc, the 0, okay? So this time when you do your left bound, it'll be above, here it's below, you can take your guess. So one of your zeros is negative 1.06. Okay, again, to make sure you're rounding correctly, feel free to write out to 3 decimal places, and then you can always look at that one behind, okay, to make sure that you got the correct one. Okay, and then we're going to go over to the other one. So you can go to the center and then go to the left. Now our left is underneath the axis, your right is here. Okay, and then your 0 is going to be when it says 0 on your screen. Okay. And you can just put a comma between those. So 0.89. All right, any questions for me on finding the x-intercepts with your calculator? Okay, very similar to things that we've done before, okay? So in example 2, it says the outside of an ice chest, should be similar to a cooler, right, is 24 inches across, 14 inches wide, 16 inches high. All sides of the ice chest have an insulating layer that has a uniform width of X inches. So you can see that they've labeled this here. Okay, the inner volume of the ice chest is 3,003 cubic inches. So we're going to write a polynomial equation to represent this situation. We're going to solve the system of equations, and then we are going to find the dimensions of inside the ice chest. Okay, so what's inside without your insulated layer? So the first thing you have is that it's 24 across, 14 wide, 16 inches high. Okay, whenever you are finding the volume, do we remember our, oops, not A, B. Do you guys remember the formula for finding the volume of a rectangular prism? Yep, length times width times height. Okay, so you would have done that in geometry last year. Okay, your volume is equal to length times width times height. Okay, and they tell you the length, the width, and the height in your first sentence. Okay, and we know that the volume of this inside is going to be equal to 3,003. What we're going to do is we're going to come up with an expression for each of these. Because this is the outside, we have to come up with something for the inside. Okay, so let's look at what we have here. You have this little part here that's X. Okay, if you have, I'm going to rewrite where the X is. So if this side is 14, what we're trying to do is we're trying to find what I've highlighted here. Okay, so if this width is X, here to here is going to be X. Also here to here is going to be X. I want you to try to write that down as an expression. Okay, you can work with the people in your row to figure that out. Okay, and let's see if you guys can come up with a way to rewrite the length, the width, and the height. Okay. If the height is confusing you, at least the length and the width. Okay, so start chatting with the people next to you to see what they're thinking.
Yeah. But are we assuming that there's a bottom to it?
All right, so a few people figured it out. A few people are very close. So if you know this whole thing is 14, okay, this whole part here, you're trying to find what I highlighted in pink. So what do you have to subtract from the 14 to get this here? 2x, not just 1, because you have x on each side, right? So if you have an x on each side, when you're doing the width, it's going to be 14 minus 2x. Okay, and then the same thing happens here, right? You have that same insulation layer on both sides. So this is x and this is x. So if you are trying to find this, you would take the original 24 and you would subtract 2x. Okay, I will say that the height one is a little bit tricky, but can you see here that you do have, like this is a different color. This is like an insulated cube that's inside it. So you do have the X here, and the tricky part with this is you can't see it, but there has to be it on the bottom too, or else the bottom would not be insulated. Okay, so there is going to be an invisible x here, so it is going to be 16 minus 2x. Okay, and if you just put the 16 minus x because you could just see this part, that's understandable. Okay, but again, you wouldn't have it all insulated except for the bottom. That wouldn't make sense. Okay, so you can go home and examine your coolers tonight if you have some. There is like an insulated layer there. Okay, so what are we going to do with these? Give me an F, give me an O, give me an I, give me an L. What does that spell? Foil! You didn't think that spelled foil? Okay, so let's go ahead and foil. Okay, so you can use your calculator to multiply those larger numbers, that's fine. Okay, and let's foil that, and then when you're ready, you can distribute. But I had to count. Once you foil, let's go ahead and distribute that last one. Okay? And then combine your legs. All right, let's see what we got. So we should have got 224, and then you have to combine to get negative 60x plus 4x squared. Okay, so 14 times 16, negative 2 times 16, negative 2 times 14, add those together. Negative times a negative is going to be a positive. And now we distribute. So when you distribute and you're multiplying everything by 24, like I said, you can use your calculator to do 24 times 224. Thank goodness, right? Okay, and then 24 times negative 60, negative 1440, and then 24 times 4 will give you 96x squared. Now, when you are multiplying by a negative, that's going to change some signs here. Again, I like to line up my like terms. So if I double 224, I get negative 448x. Negative times a negative is a positive, so that will be 120x squared. Negative times a positive is a negative x cubed. Okay, I will add these together. Add your like terms, and it is still equal to 3,003. Okay? Pardon? Oh yeah, it's not in standard form. So when I plug it into my calculator, I'm going to put it in standard form. So for A, it says write a polynomial equation to represent this situation. Okay, this is going to be your polynomial equation, and you are welcome to write that in standard form. So negative 8x cubed plus 216x squared minus 1888x plus 5376 equals 3003. Now I know some of you may have moved this over the line so it was equal to 0. Okay, that is okay. The reason why I'm not is because of part B. So in part B, they ask you to write a system of equations, and our system of equations is just going to be both sides of this equation here. Okay, so in our calculator, in y1, we're going to plug in the negative 8x cubed plus 216x squared minus 1888x plus 5376. And in our second one, it says write and solve a system. Okay, so a system has to be at least 2 equations. Okay, and when you are graphing these 2 equations, do you guys remember how you can find the solution on your graph? You're going to graph and find the intersection. Okay, so where they meet, that is going to be your solution. Okay, when you are graphing, because we're working with bigger numbers, you are going to have to go to zoom, okay, and you should go to option 0, which is zoom fit, so that you can see your intersection there. Of course, you can always play around with the window. Okay, this should just be a quicker way to do it. To find the intersection, you go to second, and again, you hit the trace button. Okay, and then number 5 is the intersect feature. Okay, your x value is going to be your solution for x. Okay, so we are going to plug these in. Negative 8x cubed plus 216x squared x Okay, then once you get those two in, let's go to zoom and option 0. Okay, so what you want to see is that intersection of the lines, okay? And the intersection is really low on mine, so when that happens, sometimes I just go to my window and I just adjust it. So what I want to see is right here. So I'm going to make that 0 to 10. I'm going to cut that in half and see what happens. Okay, that's not better, but you want to be in a place where you can use that intersect feature. I just saw it was 53,000 and that I had a lot of space up here, so I cut it in half. Okay, and then you can go to second, trace, press 5 for the intersect. Remember, you're trying to get right at that intersection. Okay, so the intersect feature is something that we've used before this year. As long as you get there, it's going to ask you first curve, you press enter, second curve, enter, guess, enter, and then it gives you the exact value. Okay, so it says your X value is 1.5, okay, when Y is 3,003. Okay, so your X is 1.5 when your Y is 3,003. Okay, so your X value is going to be your solution. And that's what we're going to use for part C. Okay, any questions for me on part B? Finding the intersection? Okay, let's check your equation. So this one looks like the end of it. This is part of the cubic function. We just can't see that graph. But you should have one that's a horizontal line. But I'll come back there and check, okay? Okay, and so when they want to know the dimensions inside the ice chest, remember that we said the length was 24 minus 2x, the width was 14 minus 2x, and the height was 16 minus 2x. Okay, if your x value is 1.5, you're just going to substitute that in. Okay. Okay, so you're doing 24 minus 3. 2 times 1.5, so it'll be 21. Okay, 14 minus 3 would be 11. 16 minus 3 would be 13. This unit is in inches. So the dimensions are 21 inches, and then we put an X for the by 11 inches, okay, by 13 inches. Okay, so what you're going to work on for the rest of the class is numbers 1 through 8. Okay, and we are going to be submitting that in